Hello guys and welcome to another video assignment. Today we are going to be talking about the topic Introduction to End-to-End Machine Learning Projects of the subject Machine Learning, and my name is Parinitham, studying Sri Venkateswara College of Engineering, pursuing 6 in the course Computer Science Engineering and Artificial Intelligence. So I'm working on an end-to-end machine learning project. Is an exciting and rewarding journey. It involves a comprehensive process of defining the problem, collecting and processing data, building and training models, evaluating their performance, and finally deploying the solution. This holistic approach ensures that the final product not only delivers accurate predictions but also meets the specific needs of the business or application. In this presentation, we'll explore the key stages of an end-to-end machine learning project, highlighting best practices and addressing common challenges along the way. So now let's talk about defining the problem and the data collection. So the first objective is to understand the business objectives. Start by clearly defining the problem so that we have a clear view on what the stakeholders require, such as collaborate with stakeholders to understand the business context, the desired outcomes, and the key performance indicators that will measure success. Second thing is to identify data sources. The data required to address the problem and identify reliable sources from which to collect it. This may involve integrating data from multiple internal and external systems. Access to data quality, evaluate the completeness, accuracy, and relevance of the collected data. Address any issues such as missing values or outliers to ensure the data is fit for analysis. Exploratory data analysis and feature engineering. Exploratory data analysis dive into the data to uncover patterns, trends, and insights. Use visualizations and the statistical techniques to understand characteristics of data, identify relationships between variables, and detect any potential issues. Feature engineering. Based on your analysis, create new feature or transform existing ones to improve the predictive power of your models. This may involve feature selection, dimensionally reduction, or the creation of composite features. Validation and testing, splitting your data into training, validation, and test sets to ensure your models generalize and well and perform as expected on unseen data. Continuously assess the quality of your data and the effectiveness of your feature engineering efforts. Model selection and training. Model selection. Based on the problem you're trying to solve, choose the appropriate machine learning algorithms and techniques. Consider such factors such as model complexity, interpretability, and inherent characteristics of a. So, model selection plays an important role because it will, by selecting an appropriate model for the desired, to get the desired output or the tasks to be done by the end users, selecting the model will be very useful, and considering its factors such as complexity, interpretability, and inherit the characteristics of your data. So hyperparameter tuning, optimize hyperparameters of your chosen models to improve their performance. This may involve techniques like grid search, random search, or Bayesian optimization. Model training. Train your models using the optimized parameters and the prepared training data. Monitor. The training process can be prepared to iterate on your model selection and feature engineering if the results are not satisfactory. So now let's talk about model evaluation and tuning. Accuracy measures the overall correctness of your model's and predictions. Precision evaluate the proportion of true positives among the positive predictions. Recall assesses the proportion of true positives that your model correctly identified. F1 score combine precision and recall into a single metric that gives a balanced view of your model's performance. So accuracy is like the overall correction and the predictions of your how correct your model is going to predict. Precision will be to evaluate the proportions of true positive outcomes among the positive predictions. Recall to assess the proportion of true positives your model has currently identified. And F1 score can be of a combination of precision, recall into a single metric, which will give you the model's performance. So now let's talk about the deployment and monitoring. Model integration. Integrate your trained model into the target application or system, ensuring seamless data flow and scalable infrastructure. Monitoring and maintenance. Continuously monitor the model's performance in production and be ready to retrain or fine-tune its new data becomes available or the problem domain evolves. Feedback loop. Establish a feedback loop to collect user feedback and incorporate it into the next iteration of your model, ensuring the solution remains relevant and impactful. Now let's talk about essential steps in model deployment to get your data pipeline ready and set, access appropriate external data, create powerful testing and training automation tools, plan and design robust monitoring, auditing, and retraining protocols. Make sure that your data pipelines are structured effectively and are capable of providing relevant high quality data. You must be sure that you are operating on with the best possible data from the most appropriate sources right from the beginning until your launch time. Rigorous and uncompromising testing and training are very casual before you proceed towards the stage of predictive model deployment. You must check that these results are accurate and also that the data you load into the model will keep these models consistent and relevant over time. Now let's talk about the challenges and the best practices. Data availability and quality. Ensuring you have sufficient high quality data to train your models, which can be a significant challenge. So you better invest in data collection, curation, and pre-processing. Model interpretability. Uh, Depending on the complexity of your models, interpretability can be a concern. Consider using explainable AI techniques to provide insights into the model's decision-making process. Scalability and deployment. Deploying and maintaining your models in the production can be complex, especially when dealing with large-scale real-time data. Carefully plan your infrastructure and monitoring strategies. Collaboration and communication. End-to-end machine learning projects often involve cross-functional teams. Effective communication and collaboration are key to ensuring everyone is aligned and working towards the same goals. Now we have come to the conclusion and what further next steps can be made to improve your end-to-end machine learning project. In conclusion, successfully executing an end-to-end machine learning project requires a holistic approach that encompasses problem definition, collection, exploratory analysis, and model building and evaluation, deployment, and ongoing monitoring. By navigating these stages with a focus on best practices and addressing common challenges, you can deliver impactful production ready solutions that drive real business values. As you embark on your next machine learning project, remember to stay curious, experiment, and continuously learn as the field of AI and machine learning is rapidly evolving. If you guys have found anything useful by watching this video, please leave a like. Thank you guys.